Yeah, they call him the goat now.
Okay, so this is a continuation of the lesson yesterday. Yesterday we learned to expand binomials using Pascal's triangle. Pascal's triangle works great, but if you have to raise a binomial to a larger power, like to the 12th power or 15th power or 20th power, you wouldn't want to have to expand Pascal's triangle out every time you want to raise something to the 15th power or 20th power. And so we have another option called the Binomial Theorem, and I'll explain how that works in just a minute. The theorem itself might look kind of scary to you at the beginning, but it's really not that much different than what we did yesterday. So just go ahead and copy down everything you see up on the screen, and then I'll work through an example with you, and you'll see that binomial theorem is actually pretty easy, especially if you understood what we did yesterday with Pascal's triangle. So go ahead and write down everything that's on the screen, and then we'll work through the first example together. Okay, so in the binomial theorem, everything is the same as what we did with Pascal's triangle, except for the coefficients that are in front. Yesterday we just got these coefficients by looking at the numbers in Pascal's triangle. Now we're using NCR to get that. So you remember when we were in the probability unit, this was how we calculated the number of combinations. NCR is defined as n factorial over r factorial times n minus r factorial. And so we will need your graphing calculator today and access to the probability menu so we can do NCR. Another way to write NCR is with the parentheses n over r like that. And so that's just a difference in notation. Some books and some teachers that you might have in the future may use this notation instead of this notation. So you just need to understand that those mean the same thing. Okay, both of these mean n factorial over r factorial n minus r factorial. Okay, and so for our first example, it's a 5th degree expansion, and so we're going to have 6 terms altogether. So we'll have 1, 2, 3, 4, 5, 6 terms. And we know the coefficients for the first one and the last one are always 1. Remember that from Pascal's triangle. It's going to start with 4x to the 5th power, 4x in parentheses to the 5th power. And then the next one is going to have 4x to the 4th power and negative 3 to the 1st power. And then using the binomial theorem to figure out the coefficient in front, we always use the power of the binomial, so that's going to be our first number, so that's going to be 5, choose. Now for the second number in the combination, we can either use the 4 or the 1, the exponents for the 4x or the negative 3. It doesn't matter because they'll both come out with the same result. 5 choose 4 is exactly the same as 5 choose 1, and that's why it doesn't matter which one of those exponents you use. 5 choose 4 and 5 choose 1, remember, are the same, because if I do 5 choose 4, that would be 5 factorial over 4 factorial, and the difference between them is 1, so 1 factorial. If I do 5 choose 1, that's 5 factorial, 1 factorial. The difference between 5 and 1 is 4 factorial. So notice that those would turn out exactly the same because they both have 4 factorial times 1 factorial in the bottom. So it doesn't matter which one of those we use. The coefficient is going to be 5 choose 4. We'll calculate that later. So let's continue on with the pattern. Now it's going to be 4x to the 3rd power, negative 3 to what power? 2nd, because those two exponents have to add up to 5. And now in front, it's going to be 5, choose. Again, look at either one of those exponents. Either one will work. I'll use 5 choose 3, but if you put 5 choose 2, it would turn out to be the same number. Okay? The next term is going to have 4x to the second, negative 3 to the third, and it's going to be 5 choose 2. And then continuing on, this will be 5 choose 1, 4x to the first power, negative 3 to the fourth power. And our last term is going to be negative 3 to the fifth power. And so now we just need to simplify all the numerical parts of those terms. And so for the first term, we have 4 raised to the fifth power. So this becomes 10, 24, x to the fifth. Five choose 4 is just 5. You could type that into your calculator like this. You could go 5, math, probability, NCR, so 5 choose 4, which, by the way, would just be 5. You don't have to type that in each time. It would just be 5. So we have 5 choose 4 times, notice here we have 4 to the fourth power. And then negative 3 to the first power, so times negative 3. That is negative 3,840. So minus 3,840 x to the fourth power. And then we can just go up and grab that expression and make changes to it. So this time it's going to be 5 choose 3, 4 to the third power, and negative 3 to the second power. So that's 5,760 x to the third power. Go ahead and use your calculators to fill in those last 3 terms. And raise your hand. I'll come around and help you if you need help. Okay, Paige, what did you get for the next term?
4320 x squared.
Positive or negative?
Positive.
So don't we have negative 3 to the third power?
So it'd be negative.
Negative. So negative 4,320 x squared. Do you guys agree with that?
Yes.
Okay. Grant, what did you get for the next term?
X 1,620x.
Positive or negative?
Positive.
Positive. Okay, do you guys agree with that one?
Yeah.
Brenna, what did you get for the last term?
Minus 243.
Okay, so that one's just negative 3 to the fifth power. So if you are just entering the 3's instead of negative 3's, you can always tell when you have negative 3 raised to an odd power, you're going to end up with a negative term. Negative 3 to an even power is going to be a positive term. Okay, go ahead and try the next one, B. And I haven't shown you how to do example 3 yet, but you can try to figure it out on your own if you want. Just make sure you write in pencil in case you make a mistake when I come back and do it with you. But go ahead and do x plus 6 to the fourth power using the binomial theorem. I'll come around and help you if you need it. Okay, so you can go ahead and check your answer. For example, B. You can look at the steps there. Anybody have a question on any of the terms for that expansion? Okay, now before we do the next example, it's asking for the 7th term only. So we don't want to have to write out all 10 terms of this and then count over to the 7th one. It'd be nice if we could just immediately jump to the 7th term. So to do that, let's recognize some patterns. In the previous problem, so look at what we have here. If we call this the first term, this is the second term, this is the third term, fourth term, and so on. Okay, now look at the term number and the powers, the exponents that we have. The first term is fourth power, second term is third power and first power, third term is second power and second power, fourth term is first power and third power. Does anyone see an easy pattern that relates the term number to one of those exponents? So that if we are at the 7th term, we would know what the exponent should be? What do you see, Lucas? Say it again. The term number minus 1 gives us which one? Gives us the second one, right? So we have, when we're looking at the second term, this number is 1 less than that. The third term, this number is 1 less than that. The fourth term, this number is 1 less than that. So the exponent of the second factor of the binomial, or the second term of the binomial, is 1 less than the term number. So if we want the 7th term, we know that it's going to have -3 to what power? 6th, because it's 1 less, which means x would have to be raised to what power? 3rd power, because those two exponents have to add up to 9. And now we just need to figure out what exponent goes in front of that, and so we'll use NCR for that. So that's 9, choose what number? 3 or 6. 9 choose 3 or 9 choose 6 will give us the correct answer there. And so then that's going to be nine choose 3 times -3 to the 6th. So that's 61,236 x to the 3rd power. Okay, so go ahead and find the 7th term of x plus 2 to the 10th. Okay, so again, if we want the 7th term, we know that's going to have 2 to the 6th, and that means x is going to be raised to what power? 4. So we have x to the 4th power, and then in front of that, so what should we put there?
10 choose 4.
10 choose 4, good. And then what's our final answer, Timothy?
13,440 x to the 4th.
Does everyone agree?